Hello everyone, welcome back to my channel. Myself Manoj Solapre. I am studying in Sri Venkateshwar College of Engineering. My topic is non-deterministic finite automata (NFA). Introductions are non-deterministic finite automata (NFA) has the power to be in several states at once. This ability is often expressed as one ability to guess something about its input. For instance, when the automata is used to search for a create sequence of characters, for example keywords, in a long text string, it is helpful to guess that we are at the beginning of one of those strings and use a sequence of states to do nothing but check that the strings appears characters by characters. The definitions of NFA. Now let us introductions the formal notations associated with NFA. The difference between NFA DFA will pointed out at will done as NFA is represented essentially like DFA. In NFA DFA there are five tuples. Q. The phi tuple is represented by Q, delta, sigma, Q naught, F. Q is a finite set of state. Sigma is a finite set of input systems. Q naught a member of Q. It is a start state. F. A subset of Q is a set of a final set states. Delta. The transitions functions of functions that takes the state in Q and the input symbols is sigma as a argument that returns a subset of Q. Notice that the only difference between as NFA and DFA is types of the value that delta returns. A set of states in the cases of an NFA as a single state in the case of a DFA. Let's see examples. An NFA accepting all strings that end with 0 1. We can see the here Q0, Q1, Q2. There is three states. Okay, the that will accept last end with 0 1. The NFA is a specified formula as Q0, Q1, Q3, 0 1, delta Q0, Q2. Whereas the transitions functions of delta is given by transitions tables. Let's see transition tables. We can see 0 1, then q0, q1, q2. Q2 is a final state, q1 is a start. Sorry, q0 is a start states. Transitions table from NFA that accept all strings ending in 0 ones. We can see the table. Notice that the transitions table can be used in specify the transitions functions for an NFA as well as for a DFA. The only difference is that each entry is a table for that NFA is a set, even if it is a singleton as one member. Also notice that when there is no transitions at all from the given states and a given input symbols, the proper entry of the languages of NFA. A NFA accept the string W if possible to make any sequence of choices of next state will represent a characteristic of W and go from the start state to any accepted state. The fact that other choices using the input symbols of W lead to the non accepting state or do not lead to any state at all. Example, the sequence of states is died does not prevent W from beginning accepting by the NFA as well as all. Equivalence of determinants and NFA. Although there are many languages of with an NFA is easier to construct that DFA, such as a language of string that end in 0 1. It is a surprising fact that can be uh, described by some NFA can also be described by some DFA. Moreover, the DFA is practice as about many states as a NFA. All through of often has more transitions. In the worst case, the however the smallest DFA can be two ends states will be the smallest NFA for the same languages has only one end state. The proof that DFA is can be do whatever the NFAs can do constructions called as subset constructions becoming the involves constructions although all of set of states of NFA. A bad case for the subset constructions. It is quite common in practice for the DFA to have roughly the same number of states as the NFA for which is constructed. However, the exponential growth in a number of states in possible all the n 2 n's DFA state that we could construct from an n state NFA many turn out to the sorry out to be accessible. The following example does not quite reach that bound, but it is an understable waveform reach n of n to of n states in the smallest DFA that is equivalent at an n plus 1 states NFA. Thank you for watching.